But we start with some review that we've looked at before. But for some of you, perhaps this is all brand new. I don't know. How does a Hawaiian baritone laugh? Hands up. Danny. Lo, ha. It's funny because hands up if you don't get it. Like it's aloha, but it's a baritone. So what are we doing? Okay. Then the second page I wanted to I did assign to you is this. This one, you had to simplify it, and then you had to substitute. What did we end up with? A rectangle. I love it.
I just don't understand why we're bringing shapes into this.
It's not a shape.
No, but a rectangle.
Yeah, but it's not a rectangle. It's a rectangle.
I just don't.
It's funny. Because it's math class, so a rectangle, but it's not a rectangle, it's a rectangle. Because it sounds like something else, Kate.
It'd be funny if it had a shape involved in it.
It's all lost on you, that's okay. Okay, so we're going to skip this beginning part because I think maybe we talk about this. Yeah, let's talk about it really fast. Forget I said what I was about to say. So we're just going to fly through this beginning thing here because y'all can do this really quickly. A plus A, what is that? That means I have two A's. Cool, like that. What's A times A? Hands up. Hands up. A times A. Yeah, 10 meet. That's A squared. Notice how A plus A and A times A are fundamentally different. One is A squared, one is, thank you, whoever said yes. Yes, Carolyn. The next one is 2A. 2 times A is 2A. So number 4 is going to be 6A. Love it. 5 is, it's also going to be 6A because 4 and 5 are written differently but mean the exact same thing. I have 2 times 3A, which was 2 times 3A. How about number 6? It is, in fact, 34A. What did you do? You, yes, Nika.
I did the 4 times 5 first, which is 20, and then 7 times 2, which is 14, and then added them together.
And then you grouped them. Cool. So how about number 7? Who said that? Is that Chelsea? No. Suchep? Suchep, louder. Correct. Are we all cool with why that is? So over here, where I had a number and then I had an expression with a coefficient and a variable, I just multiplied the number parts together. So 2 times 3 was 6, and then I'm multiplying this thing by A. I can multiply in whatever order I want. I could have had 3A times 2. It still would have been 6A. I multiply my coefficient by this constant term here. So the same thing here is true, except there is no coefficient. Now there's another variable. I've got A times 6A, which I can rewrite as 6 times A times A. The A times A is A squared, and 6 is just the coefficient that hangs along for the right. How about number 8, then? Yeah, 10 meet. Love it. We cool with why that is? And then number 9, last one. Yeah, Carolyn. 21AB. Does anyone have any questions about why that is? Yes, Carmen. Sure. So with these ones, again, so this 9 and 6 are very similar. And, well, I guess these all kind of build, 6, 7, and 8 all build towards 9. So with this one here, if I had 2 times 3b, that would just be 6b, right? But I've got 2a times 3b. So I still do what I did before. I'm going to rewrite this as 2 times 3, which is 6. And then a times b, I can't group those. Those are not the same bases. So a times b is just going to be ab. Because when there is no mathematical operator written between them, it is implied that what mathematical operator is actually present? Multiplication. So 6ab is just, I've multiplied the 2 and the 3 together, and then it's a times b. Same thing here. This one's going to give me 15 ba. Well, is AB the same as BA? Yeah. So I can group, so I can group these. And when I group things with the same variables and same exponents, what do I do with their coefficients? I add them. So 6 plus 15 is 21, and I'm left with AB. I just have to choose which one of these ways I'm going to write it, either AB or BA. Doesn't matter. Yes?
So I don't quite understand. So you have AB and AB, right?
AB and BA?
Yeah, sorry, yeah. And then, so you have 2 B's and 2 A's. So then, if you added the A is A to the power of 1, there's nothing written there. And then plus A to the power of 1 is A to the power of 2.
No, when I multiply them, I get A to the power of 2.
Right.
When I add them, I just increase the coefficient up front.
So how come, oh, never mind, I thought that was a multiplication.
That's a common mistake. That's good. I'm glad you brought it up. Thank you for being the sacrificial lamb.
Thank you. You're welcome.
Any other questions about 9? Carmen, 9 makes sense? Okay, so some language now. Expansion. What does it mean to expand things in math? Do we know? Blow them up. What does that mean?
Like, really see all the numbers that are in there. No simplification, like unsimplify it, kind of. If you have, if you had 1,298, you can expand it to 1,000 with 3 zeros.
Oh, you're thinking about it like that. Oh, okay. Yeah, no, we don't want to do that.
It'd be different with that.
Yeah, we don't want to do that.
Yeah.
That's a lot more work than we want to do. So at this stage, to expand something in the context that we're looking at, in the context of algebra, to expand something means to multiply it out. So to multiply out and group like terms. And distribution is something that we've already talked about in the context of exponents. The concept is the same, but it's functionally a little bit different. As far as the distributive property goes when we're talking about algebra, how the distributive property, does anyone know what the distributive property is in terms of algebra? 10 meet? Or was that Angel? It was there for a moment, then it flashed out of your brain? Gotcha. What if I had something like this? Does anyone know how I would tackle something like this? I've got A times B plus C. I want to expand this thing.
And do AB plus AC?
Why?
Because you're multiplying A with B and then A.
I'm multiplying A, this thing out front, by each term in the brackets. What Aminat just had us do is the distributive property. So to distribute, or to apply the distributive property, we're going to multiply.
It's just like distributing exponents, but different?
Yes, just like, but different.
Okay.
When we distribute exponents, we can only distribute exponents when everything in the bracket was multiplied together. Now, when we're multiplying on the outside in, we distribute once onto each term. It's different.
What if that was... Wait, say it again?
I will as soon as I'm done writing.
Okay.
Okay, so the distributive property says we want to multiply from outside the brackets onto each term. When we talked about distributing exponents, we were only able to distribute exponents when everything in the bracket was multiplied together. That was the only way the distribution of exponents made sense. Okay? Here in algebra, when we distribute multiplication, we only distribute multiplication onto all of the individual terms. So if all you have is multiplication, there is only one term. We have multiple terms when we add and subtract. So the thing out front gets distributed onto each term individually. So for example, if I had b plus c to the power of a, if I had this, it's all blurry, here, there is no distribution. Actually, that shouldn't say not. It should say no distribution. Okay? We would need bc to the power of a, and then I'd have b to the a and c to the a. In the context of exponents, this is how it would look. In the context of algebra, when I'm distributing, using the distributive property with multiplication, I take my thing that I'm multiplying out front, and I have to make sure that it multiplies onto each term. So we've used that language in two different places. We're using it slightly differently, which is why I try to make the point I'm trying to make over here. So if I had a bracket b minus c, what would that give me? 10 me. AB minus AC, because I've taken that A out front and I've distributed it onto everything inside. Cool, love it. When we're using letters in our math, we have, that's really the only thing we can do. There is no nice way to simplify that. But if I gave you something like this, both of these, you can do this two different ways, yes? Oh, yeah?
So, since it was addition, you multiplied it. Or no, never mind.
Okay.
I'm seeing things today.
Okay.
Not a multiplication.
Okay. So let's prove to you why this works. How could I go about tackling this thing? Yeah, Carolyn. So, okay, slow down. You said first 3 times 3. Where's 3 times 3 coming from? Okay, so I could deal with the brackets first, as Carolyn just said. 2 plus 1, that's going to give me 3. And then 3 times 3 is 9. Or I could have applied the distributive property. I can multiply this 3 from outside the brackets on the inside of the brackets. 3 times 2 is plus 3 times 1, which is, and then 6 plus 3 is. Is this ringing bells of stuff you've seen in the past? Fen? I'm hoping it's jogging a little. If it's not jogging memories, is it making sense? Okay. What do I get down here? Someone want to take a stab? 10 meat. Oh, I thought that was a hand. You're just resting your face? Never mind. You still want to do it? Okay, go for it. Okay, so what is that? What is 2 times 3x? And then 2 times 1 is? And then can I group those, or am I done? I'm done. Why am I done? Why are they not like terms? There is no x here. So I have 10 meat, rather, has completely finished the question. We are done as much as we can. This does not become 8x. Last one here. Someone else take a stab at this. Tell me what it is. Or how you do it. Carolyn? Which is? Okay. So negative 3. If you include the sign out front as part of the coefficient, it's going to be negative 3 times negative 2y, which is going to be what? Positive 6y. So that becomes add plus 6y. And then last one? Which is? Minus 3. And so we're done. Cool? typically how things are written, typically for expressions with more than one variable, we list the variables in alphabetical order with constants last. That is typically how things are done. Sorry, that says typically. This is not a hard and fast rule. Like if you don't do this, I'm not going to take marks off or anything. There are times where it makes sense to not do it exactly this way. But what we don't want to do typically is we don't want the constants to be like in the middle, buried in. You could write this as 2 plus 6x or 6x plus 2. But you would not write this thing as negative 3x minus 3 plus 6y. Either you would have this guy at the front as negative 3 minus 3x plus 6y, or you'd have it the way we've written it here. You don't throw constants into the middle of things. Cool? Love it. So real fast on your mark, set, go, this bottom chunk here. Super fast. Okay, we're done, yes? Oh, some of us haven't even started yet. Okay, Ty, what'd you get for the first one?
3x plus 12.
Love it. See if I can find Chelsea. What'd you get for 2? Love it. Olivia, did you get 3? What'd you get? Cool. Typically, though, how would we write that? Carolyn? Yeah, when we're adding a negative, we can rewrite that as negative 4x minus 4y. This is typically how we want to write that at the end. This is not wrong. It's just not convention. This is the typical way to write it. And then the last one, number 4, who's sitting around not writing things? Bryce, you look like a man who's finished number 4. You have 12x plus 6y. Love it. Cool. If you didn't notice, there's 4 more on your mark, set, give her. You gotta do French immersion. Oh. Because math and French immersion, I feel like would be harder for me.
Yeah, that would be really hard, especially if the teacher's explaining things in home.
It'd be rough.
I would know. I forget everything last semester.
I forget things from before spring break, and not this semester. It's the way things get formatted in Microsoft Word that they get outlined like this. Because you put them in order, 5, 6, 7, 8, but then to save some space, you make 2 columns, and then it just takes the bottom things and moves it up to the right. Oh, I agree, but I'm not reformatting it to do that. Okay, we're done? We're done these at 4? So, Nika, you said you're done?
No.
Oh.
I just finished writing.
What do you mean writing it? Like doing the questions?
I my page and then I wrote it.
Oh, I got extras.
Oh, you do?
Yeah. I mean, it's a whole brand new booklet, though. Yeah, they're over there. Stack on the left. I always print extras. And then you can rip out the pages that you use and throw it back over there. Okay, how we doing? I'm here. Good? You're right on your lap, right? Oh, you're all three done. You're prepared. Oh, okay. Yes. It's A minus Y. You always want to include the sign that comes before. Yes. Plus 4Y. Yes. Okay, let's take a look. Lots of you are finished and some of you are arguing. It's great. I love it when you argue with each other. It's good. Okay, so number 5. Danny, what do we get? 4x minus 2. Anyone want to go over how I did that? Or sorry, does anyone want me to go over how Danny did that? We're good with number 5. The trick there is what? How did I try and trip you up? Putting the 6 outside the set of brackets. So the 2 does not distribute past the brackets. The 2 just distributes there, and then you group your like terms. Love it. Number 6. Just Angel, yes. Say again. That's not number 6, that's number 7, but we'll do it. 9x plus 8y. Okay, does anyone have a question about how Angel did number 7? Okay, there's lots of conversation, but there's no questions about number 7? Yes? We're good? Okay. Back to number 6. Yeah, what is it? Rhea? Sorry? It is A minus 18. Does anyone want me to go over how Rhea did that question? Yes, Nika. Yes, let's do it. So, Rhea, you want to explain? Tell me what you did. Oh, good. You included the sign out front of the coefficient, and we multiplied that thing in everywhere. So that's going to give us what? 4a minus 3a minus 12, and that minus 6 just kind of hangs on for the ride. You only distribute onto the set of brackets that's present, and then we grouped our like terms, yes? So then 4a minus 3a leaves us with 1a, but we don't write the 1. And negative 12 minus 6, negative 18. A minus 18. Because negative 3 times 4 is negative 12. That's why. Who said that? Who? Angel. Number 8, Angel. Wait, hold on. Danny, was your question about 6?
Oh, see, I'm just confirming that you only distribute the one that's right.
You only distribute onto the set of brackets that is being multiplied by, yeah.
Yes, but just not the 4a minus 3
Yeah, because that's not multiplying. It's just it's just the 3 that's attached to the brackets. Yes,
Is multiplying?
no, the 4a isn't multiplied by this, so it's not included in the distribution.
But if it wasn't, you would.
If there was a set of brackets, that's a whole nother beast. Yes.
What if there wasn't?
So if I had this, then I would have to distribute this whole set of brackets in. And we're going to talk about how we do that in the next
What
chapter.
if you just had the 4a in brackets?
You wouldn't put 4a in brackets. You just have it as 4a instead of the minus
If
3.
you had something else,
Stop asking about what ifs. We'll get there. We will get there. Angel, number 8. 20a plus 22y. This is correct. Does anybody want me to go over how Angel did? Actually, not true. Does anyone want Angel to explain how Angel did 8? Hands up. Angel, explain how you did 8.
Okay, I did 6 times 4, so 24A.
So you distributed it there, so it's going to be 24a. Yeah, carry on.
Plus 18Y.
Okay, so you distributed there too, so it's going to be plus 18y. Good.
Then 4, so negative 4A.
So now that's one set of brackets done. So now we're going to the second set of brackets. There's a minus, so we include the sign to the left of the number. So this isn't just minus 4, it's a negative 4, and we're going to distribute that in. And you get
Negative 4A.
minus 4a.
And then positive 4Y.
So then it's negative 4 times negative y, which is plus 4y. And then she grouped her like terms, yes? So 24a minus 4a is 20a, and 18y plus 4y is 22y's. If you left it like this, it's not complete. It's not wrong, it's just not done. The end result is the same. You haven't shown me that you can do the whole question, so I can't give you credit for having completed the entire question. But there's a difference between me taking marks away because you screwed up versus I just can't give you everything because you didn't do all the work. Depends how I grade it, probably. If that's a 1-mark question, it's like, oh, you got halfway. There you go, done. Nice. Okay, so there is some of this is review for some of you. Some of this is not review, and that's okay. Here's what we're going to do. Here's what I'm going to assign. I got loads of these. So, ladies and gentlemen, this is going to get a little bit complicated. Put your phones away and listen up here, please. Not all of you have to do all 3 pages. Okay, so if you are sitting on the south side of the class, no, north is not always forward. You don't know which way is north? Okay, ladies and gentlemen, I'm sorry for... Guys, stop talking. Everyone stop talking. I'm sorry for the confusion. North is this way. That way is north. No, that way is north. I assure you that way is north. That way is not north. Well, that way is kind of north. That's not north.
yeah, for me now it says north. Now it says it's east.
Yeah, see, guys, you're not using a compass. You're using a device that requires cellular connection to determine which way is north, south, east, west. And you got no service in this room. North is that way. South is that way. If you are on the, what did I say before, the south side of the room? North side of the room. Okay, Southsiders. Southsiders. You are going to tell me what happened to Ray Flube after he fell off the Empire State Building. Okay? Guys, please stop talking. I want to finish this. Southsiders, you're going to do this one. Everyone is going to do this one. What should you not do if you want to get help? If you want to help get rid of graffiti, this is all of you. Northsiders, flip the page. Northsiders, you're going to tell me what the Spanish farmer said to his chickens. That is what you are doing. On your market set, giver. Read the instructions.